This formula 5, I have to prove that this here cos A plus B is equal to cos B minus sin A sin B, given cos A minus B equals cos A cos B plus sin A sin B. Now, something that I want to refer you back to, okay? We all know that sin 30 equals, sin 30 would be a half, okay? Can anybody tell me what sine of minus 30 is? You can check your calculator if you want. Minus a half. Okay. Therefore, this general assumption is that sine A, okay, sine A will get you the answer, basically sine A. However, sine of minus A will get you minus sine A. That's all in page 9 and 10 of your trigonometry notes, okay? Basically the minus angle. See the way sine 30 is a half, yeah? And see the way sine of minus 30 is minus a half. Minus a half can be written as minus sine 30. So to see the way the minus can almost come out of the brackets to make it work. Okay? That's only for sine. Okay? Let's try tan now, okay? Tan 45 equals 1. I'm just taking any arbitrary tan value. Could be 50, 60, 70, 30, 40, it doesn't matter. Okay? Can anybody tell me what tan of minus 45 is going to be? Tan minus 45, anybody?
Minus 1.
Minus 1, right? Minus 1 is the same thing as minus tan 45. So by generalizing, what I can now say is that tan A equals, I can now generalize by saying that tan of minus A equals what? Minus tan A. Okay? So by proving these two parts here, just by playing around with the calculator, basically.
Should we write those in?
You'll need them in a minute. Yeah, I'm just explaining from scratch because I need to. Okay. Next one is cos. Let's go for cos 45. Cos 45 is 1 over root 2. Anybody tell me what cos of minus 45 is? It's 1 over root 2. Can anybody explain why?
Because the root means.
Okay, ASTC, Anto-style the car, also known as everything's positive, sine is positive, tan is positive, and cos is positive. When you do a positive angle, so I'll need a colour here. When you do a positive angle, when you go plus 45, you go up this direction here. Yeah? Now, when you go minus 45, you end up in the cos region. That's why sine turns out to be negative, and that's why tan turns out to be negative. However, cos remains positive. Therefore, the generalization that cos of a minus angle, provided that A is in between 0 to 90, you will get cos minus A equals cos A. Yes?
Does that mean if you put like sine 110?
Sine minus 110, it would end up in the tans quadrant, and it'd still be negative. This is the best way to think of it, Sean, right? Pick an angle and pick a function. Sine minus 100. Okay, you go to minus 100, that's minus 90, that's minus 100. You're now in tans quadrant, your sine's going to be negative. Pick another function and another angle.
Cos 240.
Minus 240.
Yeah.
Cos of minus 240. So 90, 180, 240 you leave us around here. You're in sine's quadrant, which means that cos will be negative there. Do you get it? Okay. So that's what I specify. When we're talking about these rules here, we're talking specifically about the angle A being in between 0 to 90. Okay. Now that we understand this, what we're going to do is we're now going to grab these rules here. We're going to use them above. So just gonna go up to my see the given part we have here. Now what I did there had nothing to do with the proof itself. It's just explaining a bit about negative angles. Okay, this is where the proof actually begins. It's very quick. I want to turn cos A minus B into cos A plus B. Anybody know how to do that?
Cos A, cos B.
Replace B with minus B. Look at this. Cos A minus minus B. What's minus minus B?
B.
And then replace any B's you see here with minus B. And now all of a sudden minus minus B. Anybody? Plus B. What is cos of minus B? Plus cos B. What's sine of minus B?
Minus.
And what's plus sine A multiplied with minus sine B?
Minus.
And that's your proof done. Alright,